This is Harvard on the Map, presented by the Harvard Graduate School of Design, covering innovative ideas and thought leaders in digital cartography, Earth observation, and all things geospatial, with your host, Jennifer Horowitz.
Hello, and welcome to Harvard on the Map. I'm here with Alex Wallar, who, in addition to being the CTO and co-founder of the routing company, is also a friend of mine who is in the Cambridge area. And I'd love to hear more about the routing company and your work, and it's great to hang out. Thanks for being here.
Yeah, thank you for having me. Always excited to talk about geography and the routing company.
Yeah, so maybe for some background on the routing company's origin story. I know you dropped out of your PhD to found this company at MIT, and I'd just love to hear that origin story.
Yeah, for sure. So I was doing a PhD at MIT in computer science. It was actually to focus on robotics, but where I was working on was like multi-agent planning and optimization. And so I ended up becoming a part of this project to optimize on-demand mobility systems. So we were essentially trying to solve the Uber pool problem, but we wanted to solve it at city scale in real time to optimality. And we wanted to use high capacity vehicles instead of passenger vehicles, which makes the problem much harder to solve because there's so many more combinations. We ended up publishing a paper that showed we could service all of Manhattan's taxi demand using 80% fewer vehicles by having the passengers share rides. So once we published this, we knew that we weren't going to make the impact we desired by staying in academia. There really wasn't any pathway to start working with cities and putting this into implementation. Also, all of that work really wasn't research in the way that you would do a PhD, but more like, engineering research and building systems. So in May 2019, I decided to quit my PhD, and my co-founder, he quit his job and moved to the States, and we founded the routing company. Originally we offered an API that would allow, third-party mobility companies to plug into our routing system. But then as we, became less timid about working directly with governments and in subsidized transportation, which we work in now, we decided to actually build out a full end-to-end product. So that includes a rider app, a driver app, all the back office tools for the fleet operator, so they can easily launch and manage a demand responsive transportation system. And what we've moved to now is to directly integrate with transit. So how do we integrate with multimodal transportation? How do we connect people directly into the existing transit hubs? It doesn't really matter if you have the coolest on-demand system that's super efficient and optimal if it doesn't plug in or contribute to efficiency in the entire network, then you're not really solving the problem that you wanted to solve. So yeah, and besides that, we're working on a lot of transit equity analysis so that we can provide insights and suggestions to transit operators about where an on-demand system or more transit access would be the most beneficial to their population.
Fascinating. So for those of us who are maybe not as familiar with some of the mathematical optimization issues that exist at large, what would you say the biggest issues, and if you could give the sort of distilled Cliff Notes version of the major issues in mathematical optimization, and then how the routing company is sort of going about that?
Yeah, great question. So there is many different types of optimization. You have a lot of continuous optimization that, how do I find the minimum value in some function, right? That you kind of did in, algebra when you're trying to solve the quadratic formula. And then that's an optimization problem, and that's when it's quite easy to solve. Now, the types of optimization problems that we solve are decision problems, where we have to make a decision about, how to order two different events. So you can think of, okay, let me pick person A up and then drop person A off, and then pick up person B and drop off person B. But you have many different orders that can happen. And it becomes way more complicated the more passengers that you need to pick up. And so when this problem grows at scale, to 100, 1,000, 10,000 vehicles, actually determining the most efficient order of pickups and drop-offs, along with which vehicle should do which set of pickups and drop-offs, the space explodes, and the problem is pretty intractable. So it'd been solved in two ways before. So it was solved by using some large set of heuristics. So let's say, I'm in this city, and usually people from this region and people from this region get shared together. So I'm going to prefer that type of matching over others. So that's an example of just some heuristic that you can employ. Or a vehicle is just going to take the closest passenger to them and just throw it into their itinerary, their schedule. The problem is that unlike these big continuous functions or like the quadratic functions that we did in algebra, having a very small deviation in your input actually can have a drastic effect on the cost of that schedule, the efficiency of that schedule. And that makes these heuristics very suboptimal, just because they're not really considering potentially optimal orderings. The second way that the problem was solved was by formulating it as a large, they call them integer optimization problems. All you need to know is that I'm trying to decide on some set of zeros and ones that can solve my problem. You can use a big commercial solver like Garobi or Cplex, and then you just chuck that into the solver, you wait for a while and you get a result. The problem is that it's so slow, because those types of solvers are really not good at ordering and scheduling. They're very good at making assignments. They're very good at solving, some problems that are like, what subset of these things, optimize this function. I'm not really good at saying, this vehicle should do A, B, and C in this order. And so really, we just had this massive intractable routing problem that we needed to solve at scale. And I mentioned that I came from a robotics lab.
Yeah.
Well, robotics is all about solving intractable problems in real time. And that's pretty much the goal. Like, I have a robot with a laser on it and I have some massive map. Tell me where the robot is, and I want to do that, 30 times a second. And so we have a lot of really interesting techniques to solve these pretty intractable problems by, in a way, constraining them to where they make sense for that problem space. And we did a similar thing for our solution, our really innovative routing tech. So I mentioned, these integer optimization systems. So they're good for that, making the assignment, but they suck at actually doing the ordering and scheduling. So we said, okay, well, why don't we split the problem into two parts? We have some system that we optimize for figuring out all of the possible pickup drop-off sequence that can exist given some set of vehicles and some demand. So that just very exhaustively searches the space of possibilities in a very smart way that prunes what is simply not possible given our constraints. So when I say constraints, I mean like a maximum waiting time that we'd allow a passenger to wait for to get picked up, and a maximum delay. So that is how much past the time, if they were just to drive from their pickup to their drop off, how much past that time are they going to arrive? And so it's a way of encompassing the level of inconvenience experienced by the rider for using our on-demand bus instead of just using their own car. And so we have these bounds that make a lot of schedules infeasible because they violate these constraints. And by using those constraints directly in how we exhaustively explore the space of potential schedules means that we can very quickly prune out options that we know won't work, and then we don't even consider them as part of our assignment. So we have a very efficient way of saying, here are your vehicles, here's your demand, here's your parameters or your constraints. Give me all the possible schedules that exist from that configuration. And that's really our value add, that we can do that very quickly. And then actually determining which schedules each vehicle is going to do, we use an integer optimization system to select some subset of those schedules that minimizes a global cost function. And that way we can make these global optimal decisions on which, which schedule each vehicle is going to be assigned. And so, yeah, and the TLDR, I know it's not complicated. The TLDR is that we look at the state of the world, we compute all the schedules that are possible, and then we select some subset of them that minimize, our cost and maximize our efficiency.
Fascinating. I was thinking this entire time, this should be on a podcast. I would listen to this, and I am listening to this. I'm on my own. This is fascinating. So, okay, first question from there.
Mm-hmm.
You sent, and I on your LinkedIn, and I saw that
Mm-hmm.
you are also a fan of Kepler, and that you visualize some of these patterns, these optimization patterns, using that tool, which I love. I think it's so beautiful. So how have you used that at the routing company to help display some of these optimization patterns, and what kind of data are you visualizing?
Yeah, no, it's a great question. And so we use Kepler for many different things. We actually, in our own dashboard, we use DeckGL, which is what Kepler is all built on, and that lets us do our own custom and interactive maps that we actually give out to customers and use internally. And so for those types of maps, we display the real-time information of where the vehicle is and what it's doing. So the schedule of that vehicle, where the vehicle is, we can look into what passengers the vehicle has. And then we can also traverse the history of the fleet. So we can actually have an animated playback of what all the vehicles did for the entire day and what schedules they were assigned and who they picked up and who they missed. And that's all in our dashboard, that those back office tools that I mentioned that we give to fleet operators. We also use Kepler internally for a lot of this transit equity analysis, as well as looking at potential trips that customers have had an issue with. They said, "Oh, sorry, this probably should have been done a different way." Well, we can very easily pull up that trip by storing it as GeoJSON, and then pull it up in Kepler, take a look at what happened, and hopefully come to some type of explanation as to why that one was selected. Yeah, so we use a lot of Kepler for doing analysis. On the data side, we try to standardize everything to use GeoJSON, and we use BigQuery, which is like this Google Cloud data dump type database, and it really easily exports into CSV, and we have a lot of location data there. So for us to quickly take a look at what our request profile was for yesterday across the world, we can easily just grab that from BigQuery, save it as a CSV, and load it up into Kepler for our operations team to do analysis on. And it's been really awesome, actually, that the database is super accessible to our operations teams. So actually people focusing on customer success, people working on analytics, that they're able to just do that without any type of engineering involvement. And Kepler makes that possible.
Yeah, that's amazing. I know that it was also founded by former Uber folks. I saw your team is a lot of former Uber engineering folks. Was that intentional? Were you sort of looking for teams that had previous route optimization experience? Was that part of it?
So I think for us, we didn't necessarily want to bring, it's not that we wanted to or didn't want to, just we kind of didn't bring on people with this traditional routing optimization experience besides me and my co-founder. Yeah. And that's because in a way, being ignorant of the solutions that came in the past allowed us to innovate because we weren't sort of stuck to an original idea. And so we added people onto the team that could help actually build out our products, build out scalability. And really when you're a young startup, investing in R&D is really the lowest thing on your priority list.
Sure.
But now what's great is that we're actually getting to the point where we need to be doing those types of analytics and bringing on some experts in the routing space. Now, for like a lot of the Uber people on our team, mainly in product and operations and in our leadership team. And that was because, for us, for Menno and I, we didn't have that industrial or operational expertise. And I don't think, honestly, after being in the space for a while, I don't know if any other company does operations quite like Uber does. And they just do a really, really good job. And so we've been able to bring a lot of that, that type of operations into the routing company. Also, we were originally trying to sell an API to rideshare companies. And so, we hired a bunch of Uber people early on because we're like, this is the space that we need to play in. And so that was also a big motivation for us to get, for instance, our CEO on board, who was a former senior Uber person.
Fascinating. It's really an incredible team. I'm so excited to see the work that the routing company does. I have 2 last questions. I could literally keep you here all day. The routing company is doing really interesting work. I have a question out of personal curiosity. As someone who is truly an expert in route optimization, are you ever late, or do you have any tips and tricks to not missing a meeting or getting somewhere on time? I know that there's no left turns is a good thing that helps speed things up. Probably as a noob, that's like old news, but do you have any tips and tricks? Yeah,
actually. So for me, walkability is key. So there's actually a lot of research into the benefits in walkability. So for instance, there's a book called Street Smarts by Sam Schwartz, which I highly recommend, where he talks about this. But they did some experiments with children about if they walked to school or they drove to school, and then they found that all of the children that walked to school noticed the trees in front of the school, whereas none of the kids that drove to school did. And so just thinking even about that and your own perception of your environment and sense of place, should make you walk already. However, I walk because it lets me perfectly control my ETA. Instead of, so for instance, I like to think, I have a 10-minute, it's like a 10-minute car ride or it's a 40-minute walk. I'll take the 40-minute walk. I get the benefit of, seeing pretty places. And also I'm totally in control of when I get somewhere because walking traffic is not really a thing. And then last reason, I'm going to just motivate walking. I'm sure that I don't need to do much motivation, but there's research done by the Sensible City Lab at MIT, so Carla Roddy's lab, where they did an analysis of how people get from A to B. And actually, most people don't take the fastest route. And so what they did was they qualitatively compared the fastest route with the route that people actually took. And it's stunning to see the differences in the number of trees, the building architecture, a lot of these types of like qualitative, didn't even think about it things that we just do as humans. And I don't know, I think that's kind of neat to get a sense of place that way.
Yeah, and it doesn't hurt to get the cardio either. Yeah.
Exactly. There's a whole bunch of more research. I won't go too into it. There's also like Walkable Cities, another great book.
Walkable Cities. Okay.
I think Walkable Cities. It's there's some great literature out there. Some great books.
Yeah. Well, I've just finished finals, so I'm looking for a new read. So that's actually, I'm going to play this.
I'll send you a bunch.
I would love that. Yeah.
Yeah. If you can put it in your show notes. I can send you some books.
Perfect. Yeah. So last question, which I ask all of my interviewees on this program, is to describe a time where you were lost, whether that's physically or metaphorically in your life or career, and how you found your way back again.
Okay, so can I give you one of each?
Yeah, please.
Okay, I'd say that probably the first year at the routing company, maybe even more recently, I was quite lost in my head in a way. This is, my first job. Like I had internships and stuff in college, and then I went to grad school. So this is like my first, real job, and trying to navigate, what it means to be a young professional, trying to navigate what a work-life balance is when you're not in grad school, and trying to, navigate how people perceive you and the perception that you need to leave, even when you don't think that that's how you should behave. So I'm a pretty informal guy, but having to be a co-founder, things that you say can be taken, more seriously, and you got to be really aware of that. So kind of navigating that world has, I felt a little lost, but for me, I'm super gracious that that I've had, or super grateful that I've had these people like our CEO James and our director of product, our former director of product Bradford Church, to help guide me and be my GPS through my imposter syndrome, I guess.
Sure.
And so physically, okay, this is really funny. I have just a horrible sense of direction. Like I'm talking like I will only use Google Maps. I'll use Google Maps to get anywhere that I'm not totally certain how to get there. And it's really bad. So when I'm lost, I'm always lost. Like I'm always like, I get to a place that I've been to, 100 times, and I'm like, where the heck am I?
Yeah.
How do I get home? So yeah, so I'm always lost.
That's fair. It makes sense. It's very fitting then that you're at the routing company. You're always lost.
Yeah.
Yeah, makes sense.
It's like I religiously use turn-by-turn navigation, so we're definitely going to have the best one you can have.
That's amazing.
Yeah.
That's awesome. Thank you so much for coming on the program. It's really been awesome, genuinely talking with you, and I'll see you around. See you around Cambridge.
Yeah. Thank you very much. Thanks for having me.
Yeah. See ya.
See ya.